Hey, my awesome seventh graders. We got a lot going on this week. Got some geometry lessons going on. You guys are looking at similar figures. You're looking at congruent figures. You're looking at adjacent angles, vertical angles, supplementary angles, so on and so forth. So let's look at some of these examples. So the first thing we need to talk about is the words similar and congruent, right? So last week when we rotated, reflected, and translated figures, the image was always a congruent figure, the exact same shape and size. Today we're going to talk about dilations, which changes the size, but it does create a similar figure. So similar figures have the same angle measurements, and the ratio of the sides are the same. So it says dilation is a transformation that produces an image that is the same shape, but not the same size. It's a different size. It is either larger than or smaller than the original figure. If you enlarge a figure, obviously that means we're going to make it larger. If we reduce a figure, it means the image will be smaller than the original. So the way to tell how much bigger or smaller an image is compared to the original is through the scale factor. So if you have a scale factor of 1, if you take a triangle and say, I'm going to dilate it by a scale factor of 1, basically you're creating a congruent triangle, because let's say the triangle's on a coordinate plane, and if you multiply every coordinate by 1, you get the same number. So that means if you have a scale factor greater than 1, your image is going to be larger than the original. If you have a scale factor of less than 1, you're going to have an image that is smaller than the original. Similar figures are figures that are the same shape, but not always the same size. Two figures are similar if one is the image of another by dilation, which means each coordinate and side length uses the same scale factor. So for example, let's identify the scale factor. So you find the scale factor by writing the ratio of image over original. So here's our original. The image is larger than the original, which tells you that the scale factor must be greater than 1. So we're going to compare side lengths. So 14 compares to 7. They're in the same position, right? So if we say the scale factor is 14 over 7, that simplifies down to 2. In other words, the image is twice as big as the original, or this isn't drawn to scale, but it should be. But double check it, go back to the original and say, okay, is the image larger than, do I have a scale factor greater than 1? Because if you got the numbers mixed up, if you put 7 over 14 and simplify it, you get 1/2. But according to the picture, that doesn't make sense. Let's look at number 8. The image is smaller than the original. So what do we know about the scale factor? It must be less than 1. So we're going to put the image. So we have any of these should work. We can put 2 over 8. We should be able to put 3 over 16 or 4. No, those are flipped. I'm so sorry. I was about to say that doesn't work. See how A, AT, and GD are, the image has been flipped. So you want to make sure you're finding corresponding sides. So we can either use the numbers 2 over 8 or 3 over 12 or 4 over 16. Any of these we use, they all simplify to 1/4. These are all equivalent. If any of these were not equal to the other two, then we would say our figures are not similar. That's what I meant by the ratio of sides has to be the same. All right, here's our original. It's small. The image is large, which means our scale factor must be greater than 1. So we're going to put image over original, and we get 4. We could have also put 24 over 6. All right, our original is large, our image is smaller, so our scale factor must be less than 1. So we can put 10 over 12 or 20 over 24. And if we simplify either of those, we get 5 over 6. Or what would that be? 0.56, I don't know. It's a non-terminating decimal. All right, let's look at number 11. So here we have triangle ABC. This is the original, and remember we can tell because it doesn't have the little prime marks. So the image is smaller than the original. So we can get this by thinking, okay, well this side length is 1, 2, 3 units long, and this one's 1. Or we could look at the bottom. This one is 1, 2, 3, 4, 5, 6 units long, and this is 2. So is our scale factor 3 or 1/3? Well, the image is smaller than the original, so we have to remember it's image over original. The scale factor is 1/3. Okay, let's look at this one. Our original is in purple. Our image is large. What do we know about the scale factor? It's greater than 1, so we can compare this side length. So this is 2 compared to 1, 2, 3, 4, 5, 6. Or we could compare the bottoms, 2 to 2, 4, 6, also 2 to 6. So is the scale factor 3 or is it 1/3? It is 3, right? Image over original, 6/2. Excellent. And by the way, as we solve these, even though the side lengths are different, the ratio of the sides are the same, and the angles, the corresponding angles are exactly the same. So angle B right here corresponds to B prime. Those are both the same degrees. Those are both 90 degrees. Let's say this is, I don't know, let's say it's 50. That means A prime must be 50. If the corresponding angles are different, that means the figures are not similar, okay? What corresponds with angle A? It would be angle A1, okay? This, I guess, should really be A prime since it's the image, but. So make sure you realize that. The corresponding sides are, the corresponding sides are proportional, and the corresponding angles are equal. All right, in order to dilate a graph figure, you're going to multiply each of the x and y coordinates by the scale factor. For example, if you have a scale factor of 2, you're going to multiply your x and y coordinates both by 2, all right? So for example, our original is the red, and I know that because it doesn't have the prime symbols and the blue one does. So look at our original coordinates of B. It's -1, 3. Well, if the scale factor is 2, -1 times 2 is -2, and 3 times 2 is 6. And that will work with every single coordinate. Make sure you look at all your vertices. Okay? All right, what about this one? Here is, so A and A prime doesn't help us because 0 times anything is 0. So we have to find non-zero numbers to figure out the scale factor. So let's look at B. So B's original coordinate is 3, 3. And now its image, B prime, so this is B prime, is 1, 1. So remember, if we put image over original, there's our scale factor. Or we can compare it this way. If this side length is 3, this side length is 1, this is the image, 1/3 as well. Here we'd have 6/2, or 2/6, I should say. All right, so the scale factor is 1/3. All right, what's our scale factor? Well, let's take a point. Let's take letter A and compare it with A prime. All right, A's coordinate is -1, 2, 3, -1, 2, 3. So -3, -3. I don't know why my pen does that every now and then. And then A prime is -2, -2, -2, -2. And then we put image over original. A negative divided by a negative is +2/3. Our scale factor is 2/3. And that must work for all of the coordinates. So you need to go back and check that. What about 15? Well, this side length is 1. That's the original. The image is 1, 2, 3, 4. So what is the scale factor? Is it 4 or 1/4? It's 4 because it's image over original. Make sure all the sides are corresponding. It says to determine whether they're similar. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2. So 8 over 2 is also equal to 4. So they are similar. All right, now if we want to find our new coordinates, we're just going to take our original points, like h is at 2, 2, and we're going to multiply them by our scale factor. So our scale factor is 5, so 5 times 2 is 10. 5 times 2 is 10, so h prime is going to be at 10, 10. All right, so here will be h prime, way up here in the corner. G would be at negative 2, 2. It's going to be way over here at negative 10, 10. Anyway, it's a big figure. And the same thing with this one. If L is at 4, 4, and our scale factor is 1/2, half of 4 is 2, 2. So we're just making a little square right in the middle. So you would just take each of the coordinates and multiply them by your scale factor. All right, so you guys practice that on this paper. So what if we dilate this by 1/2? You guys can do that on your own. All right, so here it says, the question is, what set of transformation, that means at least 2 things have been done to our original triangle to get the image. So first of all, we have to identify the image, which is the one on the right, because we have double prime marks. The reason we have double prime marks is because 2 transformations has happened. So we got to identify what has happened. So the first thing I noticed is that Z and Z prime, one of them's been flipped, right? So let's start with that. Let's say I flip this figure over this y-axis. So if I am 3 to the left of the line, if I reflect it, I'm going to be 3 to the right of the line. So I'm going to imagine that this is Z prime. I'm going to make sure this works. Y is 6 to the left. I'm going to make it 6 to the right. That's Y prime. And then X is 5 to the left. I'm going to make it 5 to the right. And if I connect those dots, I feel pretty good about that. I feel like those are the first transformation. I reflected over the y-axis. All right, now I'm going to look at Z prime. Z prime's coordinate is 3, negative 2. And Z double prime's coordinate is 6, negative 4. 6, negative 4. So what would I do to 3 to get to 6 and negative 2 to get to negative 4? I would multiply each of those by 2. So the second transformation is a dilation. It's not dilation, by the way. It's dilation. Uh-oh, I spelled it wrong anyway. Dilation with a scale factor of 2. So that's my 2 transformations. I reflected this triangle over the y-axis and I dilate it with a scale factor of 2. And it doesn't necessarily have to be one first. And I could have dilated it first and then reflected it. It wouldn't have changed the figure. All right, going on past dilations, now we're going to have some vocabulary terms. Now these are just 3 of the vocabulary terms. You have, I think, a total of 6. So vertical angles, supplementary angles, alternate interior angles. So your angle pairs are either going to be supplementary, which means that 2 angles added together is equal to 180 degrees. Or they're congruent, okay? So, you know, if I took the measure of a straight line, straight lines have a measure of 180 degrees. Well, if I divided it into 2 angles, I still know that this angle plus this angle has to equal 180 because they form this straight line, right? So if you have 2 angles, when you add them together, they equal 180 degrees. That means they're supplementary. Well, if they have a common side, like this one that I just drew, this angle has a common side with this angle, which is this side right there. They're next door neighbors. They live beside each other. That means they're adjacent. So angles 1 and 2 are 2 things. They're adjacent because they share a common side, And together they form this straight line, so they're supplementary. So angles 1 and 2 are adjacent, which I didn't type that word, and supplementary. Now, I could say a lot of these angle pairs are both of those things. 2 and 4 are adjacent and supplementary. 3 and 4 are adjacent and supplementary, and 1 and 3. And down here on the second parallel line, or the other line that makes these two parallel, I have the same type of pairs. 5 and 6, adjacent and supplementary. 6 and 8, 7 and 8, and 5 and 7. Okay, so adjacent and supplementary, two angles that are, when you add them, they equal 180. Now, if you have two angles that are across from each other, they share a common vertical or vertices, they are vertical angles. And vertical angles are congruent. All right, so vertical angles are always congruent. That means they're the same measurement. So 1 and 4 are vertical. Also, 2 and 3 are vertical and congruent. 5 and 8 are vertical and congruent, and 6 and 7. And look at them. Doesn't that make sense? Look at angle 6. Isn't it a small acute angle? Well, angle 8 isn't a small acute angle. It's obtuse. It's greater than 90 degrees. But 6 and 7 look the same, and they are. They're both acute angles, and they are equal, and they are vertical. Okay, so you guys are just going to have to memorize those vocabulary terms, and they're in the lesson. So question 1, so one of the other words is corresponding. It means where on the other parallel line is this in the same position. So corresponding angles are in the same position on the other line that makes them parallel. So angle 5 and angle 4 are corresponding angles. They're also congruent. Look how big, wide, obtuse angle this one is. Number 4 looks exactly the same. So 5 and 4 are corresponding and congruent. What else is corresponding and congruent? 1 and 8, 2 and 6, 3 and 7. Question 2, if the measure of angle 8 is 48 degrees, so this one's 48 degrees, now we can find the rest of all of the other angles. It asks about angle 1. Well, 8 and 1 are corresponding, and corresponding angles are congruent. Well, what else do we know? Well, we know that 8 and 6 are vertical angles and they're equal. So 6 is also 48. Well, look at 8 and 5. Aren't 8 and 5 supplementary because they form this straight line? So if they're supplementary, we're going to subtract 180 minus 48 to figure out what angle 5 is. Well, angle 5 is 132. If angle 5 is 132 degrees, what is angle 7? It's also 132 degrees. 7 and 3 are corresponding, so that means they're both equal, 132 degrees. Angle 4 is vertical and equal. Angles 1 and 2 are vertical and congruent. All right, so if you have two parallel lines cut by a transversal, that means it goes across both parallel lines, then you just created all those types of angles. Vertical, corresponding. Oh, and there's one other one. The other one's called alternate interior angles and alternate exterior angles. So if you're thinking of interior, so think of this as a house. We have 4 angles inside the house. These are interior angles. So if you think of alternate interior, that means they're on opposite sides of the transversal. So 1 and 6 are alternate interior angles. 4 and 7 are on opposite sides of the transversal. So they're alternate interior angles. And alternate interior angles are congruent. They're the same exact measurement. So then if these are interior, that means 5, 8, 2, and 3 are exterior angles. So alternate exterior angles are congruent. So 5 and 3 are alternate exterior angles, and they are congruent. And 2 and 8 are alternate exterior angles, and they are congruent. All right, so here the next question says angle 2 and blank are alternate exterior angles. So exterior means outside the parallel lines and alternate means opposite sides of the transversal. So 2 and 8, angle 8 are alternate exterior angles. Angle 6 and angle what are alternate interior angles inside the parallel lines, so 6 and 1. The next one says angle 1 corresponds to, that means in the same position on the other parallel line. So angle 1 corresponds to angle 8. They're corresponding angles and equal. What is true about angles 5 and 8? 5 and 8, 2 words. Give me 2 words. They are adjacent because they share a common side, and they're supplementary because together they equal 180 degrees because they form a straight line. All right, now let's look at these. So we have a pair of parallel lines and we have a transversal. So this is a transversal because it crosses both parallel lines. Well, as soon as you put a transversal that crosses parallel lines, you create all those angles we just talked about. Well, one of the angles is alternate interior angle. So angle 85 and this, so ignore this line for a second. If that line wasn't there, we would say that angle 85 and this angle are alternate interior angles, and alternate interior angles are equal, right? That means that angle X plus angle 25 must equal 85. Angle X plus angle 25 must equal 85 degrees because, I guess I shouldn't put angle 25, it's 25 degrees, because these two are alternate interior angles with angle 85. So how would I solve for X? I would simply subtract X from both sides. No, I wouldn't, just kidding. I would subtract 25 from both sides. So X has to equal 60 degrees. Because 60 plus 25 is equal to 85, okay? So you would use that vocabulary term, alternate interior angles. All right, now moving on real quick to triangles. The inside angles, 3 inside angles of triangles is always, always, always equal to 180 degrees. So angles 1, 2, and 3 are equal to 180 degrees. Now, 3 and 4, these are supplementary angles because they form this straight line, right? So angle 4 is an exterior angle of this triangle. And you can think, well, whatever angle 3 is, 4 is supplementary to it. So if I knew what angle 3 was, I could subtract that number from 180 and get number 4. Or it's always equal to the sum of the inside angles. So angle 1 and angle 2 always equals the same degrees as that exterior angle. Angle 1 plus angle 2 is equal to angle 4. That's called the triangle exterior angle theorem. Okay? All right, so this one shows us that we have 2 triangles. So here is W is they're sharing a vertices. So angle W belongs to the top triangle and the bottom triangle. And what's true about these 2 angles? They're vertical, which means they are equal. So whatever this equals measurement is, this one is too. So since these are equal, and we see that V and X are equal, they're both 50 degrees, what does that tell you about angle Z? Angle Z must equal the same as angle Y. So the question is, what is the measurement of WZX? So whatever that middle letter is, that's what it's asking you. It's asking you for angle Z. Well, angle Z is exactly the same as angle Y. Angle, whoops, what is that? Angle Y is equal to angle Z. Because angles W Those are vertical and equal. 50 degrees is equal, which makes U and V, they both have to equal the same number of degrees. All right, so this is one of those exterior angles. So remember I told you the angle P is equal to N plus M because it's an exterior angle to this triangle. So the question says, or the statement says, the measure of angle M is 45 degrees. And this isn't drawn to scale, of course. The measure of angle O is 55 degrees. What is the measures? What are the measures, it should say, of angles N and P? Well, we could think of O and P as supplementary, so we could just subtract 55 from 180 to get P. And then A, B, and C are triangles, angles of triangles, so together all three of those equal 180, right? So there's a couple of different ways we can do this. So I'm just going to subtract. I know that O and P are supplementary angles. So I'm just going to subtract 180 minus 55, and I got 125. And I know that angle P must be equal to A or M plus N, because this is an exterior angle. So 125 minus 45 is equal to 80. So angle N is 80 degrees. So then we can double check it. We got to make sure those three inside angles are equal to 180. So 80 plus 45 plus 55 is in fact 180 degrees. So like I said, a couple of different ways we could find that. All right, today I computed the prime coordinates when given the scale factor, and we did even more than that, right guys? All right, woo, that was a lot of stuff, you guys, but it's fun, it's easy, it's like putting a puzzle together. And so anyway, I hope it's not too confusing. I hope you guys enjoy the geometry unit. And if you need me this week, let me know and I'll be happy to help you. Everyone have a great week.